I went on the 11th scheduled date, and that doesn't mean that I suited up 11 times. Sometimes we'd schedule a date, and when it would come a day or two before that date, there'd be some equipment thing. We knew we couldn't make that deadline, and so we canceled the flight. There were 4 times that I actually suited up. Once the flight was canceled because of weather when I was on the way to the launch pad, and one other time there was an equipment problem, and another time weather when I was up there on top. So I was actually up on top, and one time was up there for over 6 hours and then had the flight scrubbed. So when we finally went on February 20th, it was a real surprise, and something we'd gotten used to getting ready and then having it pulled out from under me. So, but I was just glad to get going that day. Up there, you're in steady state 0G, and as I said, 0G, and I feel fine. I think that was my first report of it, because some of the people ahead of the flight had thought there might be some, you might have some bad reactions to it. For instance, some of the ophthalmologists were concerned that your eyes might actually change shape in orbit when they no longer have to be supported the same way. And you might wouldn't even be able to see the instrument panel enough to make an emergency re-entry if that became necessary. There were some were concerned about that the fluid in the inner ear might move about more randomly and give you nausea and vertigo. Once again, knock you out of participating or even seeing what's on the instrument panel. And things like that, or they didn't know whether you could swallow or not in 0G. Would that be normal? So all of these were things they wanted. And could you even control a spacecraft by looking out the window and looking at the horizon and controlling it with a 3-axis hand controller we had developed? So those are some pretty fundamental things, and it was a great pleasure to find out that these worries were not coming true up there, and that everything was working out okay. Well, I think there were some things that we hadn't planned on, and those are the things that required a little bit of time. At the end of the first orbit, the automatic control system I was on at that time to control the attitude of the spacecraft, that automatic control malfunctioned and was using too much fuel, and we had planned to stay on automatic for the first couple of orbits and then see if I could take over manually. And as it turned out, I took over manually at the end of the first orbit and went to, instead of doing it one axis at a time, roll, pitch, or yaw, I went to full control manually, and just and it worked out fine. I could do it, and it was much like the reaction we had on the simulator. And then another one was at that first sunrise, or what we called the fireflies, and it turned out they were particles, moisture particles from the heat exchanger. But what they looked like it looked like you had just looking out, it was like looking out in the meadow with a million fireflies out there, except you turned them on and they had that glowing, luminous color. And we hadn't expected that. That was something brand new. And the scientists figured out later, after my flight and Scott Carpenter's flight, which was the next one, that they were particles from the heat exchanger, but they were a great surprise at that first time. While we know that that's where they came from, I don't think anyone to this day has ever really figured out exactly why they had that golden luminous color when the light comes to you from the sun through the Earth's atmosphere and back out to the spacecraft again just at sunrise. But that was another surprise. And another one then was near the end of the flight. I received a call from the ground. They had received signals on the ground at 2 different tracking sites that the heat shield was loose, and it was supposed to only come loose once you're down and are hanging on the main parachute and are coming down toward the water. That's when it is supposed to release and drop about 4 feet on extending a rubber bag that gives you sort of a cushion landing, which is particularly valuable if you had to make an emergency and come down on land. But it was that signal then meant that we had to leave the retro pack on and let it burn off during re-entry. And that was quite spectacular from where I was, because as I looked out the window, there were big burning chunks of that coming back by the window. fear, but fear that would overcome you and make you act in a different way, you overcome that. You've trained very hard for the flight. You don't let that overcome you. Were you aware of the danger? Yeah, sure. But the best way to work through that danger was just to keep on doing the things that I was doing during reentry, keeping the spacecraft in the proper attitude for reentry, because you have the heat on the heat shield is around 3,000 degrees, and the heat in the ionized layer of air that builds up about 3 or 4 feet ahead of the spacecraft coming back in gets up around 9,000 degrees. Now that's almost like the surface of the sun, and so it's extremely hot back there, and your ablation shield protects you. But if there's any doubt about that ablation shield or the heat shield working, why it'd all be over pretty quick up there. So yes, I was very much concerned about whether the heat shield was going to hold or not, specifically since we did not have any data on making a reentry with the retro rocket pack in place in the middle of the heat shield.